Welcome everybody. Thank you for joining us today for this webinar. Real quickly, I'll review the agenda. We'll have a very brief background on NREL and an overview. Then I'll talk about this procurement process and the schedule. We'll talk about the evaluation criteria to be entered into this procurement process. And then we will talk with our technical folks about the various testbed descriptions and the evaluation criteria for when you're actually entered into the procurement competition. And then we'll leave as much time as we can for questions and answers at the end. So more information is available at this link on the bottom of this slide. It's also in numerous slides throughout this deck. So the National Renewable Energy Laboratory was founded as the Solar Energy Research Institute in 1977 during the Carter administration. It was designated as a national lab by the first George H.W. Bush president in 1991. And today it is managed by the Alliance for Sustainable Energy for the U.S. Department of Energy. We do about $400 million annually in R&D activity. We have about 1,700 employees on our campus in Golden, Colorado, where the Energy Systems Integration Facility is located. And we have many, many active partnerships with industry, academia, and government. So if you did the math, you'll see that we are turning 40 years old this summer, and we're having our 40th birthday party in July. So the Energy Systems Integration Facility is pictured here. This is our newest and largest facility on campus. It houses 15 state-of-the-art laboratories that are available to the broader research community. So the ESIF is designated as a national user facility, meaning that the federal government has provided these laboratories for use to the broader research community. We have space for 200 staff members and visiting researchers in our offices. We also have a petascale supercomputer that you see here in the middle, the high performance computer, or HPC, and then the laboratories are at the back of the building there. So you can think of the ESIF as a distribution grid in a box. Our labs are interconnected with a research electrical distribution bus, or what we call the Red B. We also have thermal and fuel data infrastructures that connect some of our laboratories. I mentioned our supercomputer. It is the 30th fastest computer in the world and the fastest that is dedicated solely to renewable energy and energy efficiency work. And it drives our 3D visualization room, which you see pictured on this slide in the top left. We have multiple hardware in the loop setups, including controller hardware in the loop, power hardware in the loop, a smart home in the loop, and an apartment in the loop with our newest addition of an eye unit in one of our labs. So today we're really here to talk about a dual stage competitive procurement for a microgrid control technology. So we are piloting a new way of evaluating technologies to purchase and install here at the ESIF. And what we would like to do is have sort of a test drive between both NREL staff and potential offerers so that potential offerers get access to the test beds where their equipment would be installed, and they have a chance to actually improve and advance their technology before we make our final selection. So this is a new process for us, and we're excited that you're interested in checking it out. We'll have two stages. Stage one is the letter of interest, where we will take a look at all of the applicants to the letter of interest, or all the responders to the letter of interest, and we'll choose 5 to enter into this competitive procurement. And those 5 will have access to controller hardware in the loop testbed. They will also receive a cybersecurity review. The top 2 from that process will move on to the second stage, and the top 2 will become offerers and receive the formal RFP, or request for proposal. During stage 2, the top 2 performers will get access to a power hardware in the loop testbed. They will also be extensively tested in our cyber physical testbed, and we will ask for their cost proposal, and so that will be part of our evaluation only for stage 2. And then the top performing control technology will be installed in the ESIF in 2018, pending, of course, successful procurement negotiations. So you can see the top picture here is the Power Systems Integration Laboratory. That is where this pre-procurement evaluation will take place, and that's one of our 15 labs in the ESIF. So we are looking for a control technology that will meet the functionality needs of a research test bed. So we are not dictating any specific architecture, but we do need the controller to be as open, flexible, user configurable, and secure as possible. It also needs to be able to accommodate multiple microgrid types and use cases. So you might imagine in a research test bed, the end devices and the communications protocols are going to change periodically, and we need to be able to have our staff at NREL be able to configure those on their own. So that is quite important to us. So stage 1 includes responses to this letter of interest. It's 14 weeks, and it will start on staggered dates beginning on June 19th. So the first step is that we will send the detailed instruction packet to the first team on June 19th, and then they will have 8 weeks to program their controller and ship it to NREL. That first team will come on site at step 3, and that is when they would arrive at NREL. That's August 14th. And they would have 1 week to integrate their controller into the controller hardware in the loop test bed. During this time, they will also have received a cybersecurity questionnaire and will be expected to respond to that questionnaire. So after that first week of integration, there will be a 4-week R&D period at home, or break, whatever people want to do at that period, where the teams can still connect to their device. You can still remote into your device through a virtual private network that we'll set up for you. But there's no access to the controller hardware loop in the loop test bed at that time because other teams will be accessing it. And then that team 1 would come back to NREL if they'd like, or they could just VPN into the test bed and work remotely to have another week to improve their technologies in the controller hardware in the loop test bed. At that point, NREL will conduct a final evaluation on the controller hardware in the loop test bed and do the cybersecurity scoring. So NREL staff will do that independently on the last day of access to the test bed. So that is how we will down select to the top 2 teams, and then those top 2 teams would gain access to the power hardware in the loop test bed and receive the RFP beginning on October 23rd. So the first, we'll call these the stage 2 teams, are now offerers because they're going to respond to an RFP. And the first RFP will be given to offerer number 1 on October 23rd. The second offerer would receive it on November 6th. And this is a 7-week process where the teams have access to power hardware in the loop again in 2 different weeks. So on step 7, the team can come to NREL and work physically in the lab, which is pictured here, the Power Systems Integration Laboratory. Then there's a 4-week break or R&D at home. And during this time, you just might want to note that it's Thanksgiving week. Also during this time, Irfan's group will be taking the controller into the cyber physical test bed and doing some extensive testing on the controllers. But he promises me he will do nothing malicious to them. So then in step 10, they can go back into the power hardware in the loop test bed for the final week of R&D, and then the NREL evaluation will happen on that Friday. After that, the offerers have 1 week to submit their final cost proposal to NREL. And for step 2, the power systems score counts for 70%, the cyber score counts for 20%, and the cost proposal is considered at 10%. Okay, applications. Application information is available now. This is a picture of our website that is live. If you click that play button, there's a 7-minute video where you'll see Brian Miller give a walking tour through the laboratory where this will take place and show you all the equipment. You must respond to this letter of interest if you want to be considered for this opportunity. And to do that, you first have to register online. Once you register online, you'll get a link to the submission portal. You need to respond to the LOI by the deadline, which is June 2nd. You must certify that you meet the eligibility requirements and the minimum qualification requirements. You need to accept the terms and conditions of becoming a non-proprietary user without modification. And you must demonstrate that you have the necessary organizational support to be able to travel to NREL and work on site. So very important tip on the bottom, please read all 3 documents that are on this web page. This includes the solicitation for the letter of interest. It also includes details about the competitive procurement. So that would be after you were selected as one of the 5 participants. Step 2, the dual stage procurement details, that really outlines all the details of the competition. So that tells you what you're getting yourself into in all detail. And then of course the user agreement is there. You do not need to submit when you register. So when you register, you're simply going to get a link to the portal. So then you will be able to see all of the information. When you register, you're also going to be asked to indicate a few times where you would be available for a clarifying call the week of June 5th. And once you register, then you will have that link where when you're ready, you go ahead and fill out an online questionnaire about product functionality. And then you will upload a document up to 10 pages that has a title page, up to 6 pages of a body, and then some supporting documentation. All the details of what goes in there is available on our website now in those documents I referenced on the last slide. And then please choose a time for a clarifying call if it's needed the week of June 5th. So once you go to upload and do the online application or response, you do have to do that in one setting. You can't save that and come back. But you can register and just save that link and then do that at any time before June 2nd. So I did list out the minimum qualifications. I won't read them here, but I wanted to make sure to call attention to these during this webinar in case you have specific questions about the minimum qualifications. The selection criteria to become one of the 5 participants is listed on this slide. So you can see that 50% of the score is going to be our assessment of the extent to which the technology is open and flexible and will work for us in a research test bed here at ESIF. The product offering equates about 30% of the score. Now this includes the current functionalities of the product and additional functionalities that you plan to implement over this, is it 21 weeks? 21-week process. So when you take the online questionnaire, you'll have a choice between, yes, this is already a function in my product, or it's not a function yet, but I plan to implement it, or no, we are not going to implement that product. So it's actually a scale 1 to 5 where you can choose what you'll do with that functionality. And then the last 20% of the score is the team's expertise and your organizational support. Because you will be coming into the ESIF, working in these test beds, you know, as users on your own largely, other than support from our engineering staff to make sure that your experiments are set up correctly and safe. So this last slide on the process is here with some dates before we get into the technical details. Just wanted to call attention to May 15th, which is when I'm asking people to register by. This is not a strict deadline. This is really more for planning purposes. And if you are owned, if your parent company is foreign owned, the quicker you register, the quicker I can get the approvals going for your participation to be able to come on site at the ESIF. So in the actual response, I do ask for country of citizenship for people who will be coming on site at ESIF, and that is because we wouldn't want to run into somebody not being allowed to come onto federal property if you were selected. So please register as quickly as you can, especially if you are owned by a foreign company. Last day to submit questions is May 26th. You can email those questions either to myself or Brittany Decker. We're listed as contacts in the solicitation. Responses are due at 5 p.m. Eastern, that's 3 p.m. Mountain Time on June 2nd, that's a Friday. And please keep some time slots open for a 15 to 30 minute clarifying call between June 5th and 9th. And then we will go ahead and make our selections and notify people within 10 days, with the first team being emailed their instruction packet on the 19th. So with that, I will hand it over to our technical staff to talk about the test beds.
All right, so here at the Energy Systems Integration Facility, we have several microgrid test beds that we've created so we can actually use hardware instead of pure computer simulation. You can see that each test bed does have a real-time simulation platform, which allows us to scale that to hundreds of devices and actually model an entire actual location, which could be a campus or a city or a port, etc., and then allow those hardware devices in the lab to interact with the virtual devices in an actual location in a very realistic fashion. We also have fully controllable AC sources that allow us in a bidirectional fashion to control every aspect of the voltage waveform, including its frequency, so we can replay disturbance events for voltage or frequency and let the microgrid respond to that and try to mitigate, either ride through or disconnect itself from the grid and become an island. Each test bed has smart PV inverters. Smart means they can communicate and also have advanced grid support functions such as volt, var, and frequency watt type of controls, as well as curtailment, and of course load banks to absorb the power. We have 4 different nominal power levels in our test beds, anywhere from a 10 kilowatt, which is a single phase residential type voltage level, up through 100 kilowatts, which brings in the 3-phase commercial voltage levels, as well as some generators, microturbines, electric vehicles, and the POI, point of interconnect switch in hardware. Our 1 megawatt microgrid test bed is actually the entire Energy Systems Integration Facility, and we're currently working to increase that to 2 megawatts. That brings on some additional DC sources, hydrogen facilities, as well as our 13.2 kilovolt outdoor testing yard. Our 10,000 kilowatt microgrid test bed is the ESIF coupled with our National Wind Technology Center, which has multi-megawatt wind turbines installed in hardware a short distance from here with a remote real-time link between the 2 systems. They also have a 5 megawatt dynamometer, an actual solar array at the megawatt scale, and it's very interesting that we actually own a 115 kV section of transmission line in our own substation. So there's a lot of capabilities for testing microgrids up there. We also have some empty container pads which have wiring to them up to 8 megawatts for containerized equipment to come out and be tested. As you can see on the slide, I've highlighted the 100 kilowatt one in red because that's the power hardware setup that we're going to use for this procurement event. But keep in mind that each of these is only intended to show a small subset of equipment. The actual scaling of the hundreds of devices and the complexity of the system is given by the real-time simulation platform, which we'll show you in a later slide. So this is just a graphical depiction of those 4 different test beds. And you can see the 10 kilowatt is actually mounted on a rolling cart. It has a battery that's in hardware, and it allows us to do quite a few different power systems use cases at a small scale, such as PV smoothing, where we look at the clouding events on a PV inverter, and we use the battery to rapidly respond to those and present a nice even power level to the utility company. The 100 kilowatt is our power systems integration laboratory, where we've recently got this grid nice and integrated with real-time automation controllers, and I've pulled a lot of Ethernet cable to all of these devices, so now they're all interconnected and ready for your microgrid controllers to show us what you've got. The ESIF is the 1,000 kilowatt quad. That's our entire building, and you can see kind of where our equipment is located in different laboratories, all interconnected with our research electrical distribution buses, SCADA buses, and thermal buses. And then our 10,000 kilowatt microgrid test bed is shown, and we also have some backup slides if you need them, show what we have up at our National Wind Technology Center. You can see the wind turbines, energy storage pads, our controllable grid interface, which is our controllable AC supply up there, has a rating of 7 megawatts, and it can surge up to 39 megawatts to do very realistic fault testing. Now I'll turn it over to Shamak to describe more about the Banshee model that's running in our real-time simulation platform.
Thank you, Brian. To allow a fair comparison of microgrid controllers, we've prepared a testbed here in ESIF, which consists of both part implemented in real-time simulation and part being implemented in our power lab. The slide shows the single line diagram of a complex radial distribution system with generation reaching up to 20 megawatts. It is actually a Banshee model developed by MIT Lincoln Labs that is going to run in a real-time simulator using our Opal RT system. It consists of 3 radial feeders supplying a real-life industrial park presenting challenges that will be found in community microgrids. It consists of multiple categorized loads, actually 3 generators, 4 megawatt diesel generator and 3.5 megawatt combined heat power natural gas turbine. We also have 5 megawatt photovoltaic installation and a 2.5 megawatt energy storage system, and more than 50 circuit breakers that can be controlled by a microgrid controller, which in this case is a device under test. The last node of the system, the most on the right, shows the PHIL box. And this is actually the place where we will interconnect our simulation, real-time simulation, with a real system. The idea is that the voltage measured in simulated system will be replicated in our real lab in real time using a grid simulator. Then at the same time, the current being injected back to grid simulator will be measured in the real lab, and then this will be feedback to real-time simulation model. And this way, we will couple the simulation and real lab experiment. And the advantage of this approach is that the microgrid controller will be able to not only communicate with simulated devices and simulated interfaces, but for power hardware in the loop part, it will actually have to face problems related with the connection to real devices, including the communication delays, various communication protocols, and let's say safety and protection type of issues, which you can imagine in a real lab environment. During controller hardware in the loop part, so this is the first stage of the procurement, the PHIL node will actually be replaced with a model of all of these devices which are going to sit in our lab. So the first stage of the procurement will be done entirely in simulation, so that basically we don't have to be afraid about safety issues or protection type of problems. Only in the next stage we will replace this node with real power hardware in the loop experiment. And the next slide shows the single line diagram of the setup which we are going to have in an energy storage integration facility in our labs. So this of course consists of a microgrid controller which will be a real which will be device under test, and then this will be coupled to we have a grid simulator which will be essential part of the interface between our real-time simulator. And then we have a multiple of assets which can be controlled by microgrid controller, consisting of a 18 kilowatt generator, diesel genset, 250 kilowatt energy storage system, 100 kilowatt PV, and real circuit breakers, ABB circuit breakers. Additionally to that, we have a load bank, 250 kilowatt, which will be simulating multiple loads, also categorized as similar to Banshee model. We will also have a car connected to this setup, which will act as a load. And car will be connected to the system using a spark meter. Now to the next slide. To be able to fairly compare the performance of all the contestants, we've developed the key performance parameters that we will use in that purpose. We basically have 7 of them, and each of them, as a result of each of them, we will have a value which will be converted into US dollars, so that after assuming all of that, we will be able to present a microgrid operator's appeal. This is the nice way so that we can compare. Of course, it will not be, it will be hard to actually place this US dollar value into some place in the world, but what's important is that relative values will show us the comparison between different technologies in few different areas. And these areas are resiliency and reliability. So here we will actually look at the amount of energy delivered to each category of a load. Then we will look at the microgrid survivability. So we will look at how a microgrid controller is preserving the energy in case of unintended islanding. And then we will look at the power quality, so what voltage and frequencies violations against the IE 1547 standard. And then we will look at fuel-free asset utilization. So the amount of, so actually we will use the amount of energy that we were able to use from PV, which is basically free and fuel-free. And then we will look at how microgrid controller is able to follow the interconnection contract and how it's able to follow distribution service operator commands. Then we will look at operation and maintenance costs, those including fuel usage and maintenance type of values, like how many times the circuit breakers are actually used. So now I would like to give a voice to Erfan, who will speak a little bit more about the cybersecurity.
Thank you. So if we could get a little closer to this thing. A big part of the evaluation of these microgrid controllers from a cyber perspective has to do with their flexibility of fitting into a practical environment. Because even though we're a research facility, when we want a microgrid controller for research, we have to have it be interoperable with a variety of technologies that exist today in our building. So it's very important to have that. Cybersecurity occurs in two ways. You can either put a lot of cybersecurity controls on your technologies themselves, or you can integrate your alarming capability with the alarming capability of the rest of the building in order to provide a more integrated view for situational awareness and also for incident response. So if you look at the cybersecurity evaluation, the minimum requirements is like oxygen and water and vitamins. You just absolutely have to have that these days in order to peacefully coexist with other technologies. The Internet protocol is part and parcel of communications today, so you have to have an IP-based microgrid controller. We're not going to be looking for adapters to go from your proprietary protocols to an IP protocol. So please make sure of that. Second, there has to be an endpoint security in your microgrid controllers that if someone has direct physical access to these microgrid controllers, that there's a strong username and password capability that doesn't allow you to connect a password cracking software and within hours or days you can break into it. So make sure that your microgrid controller has that. The other thing is that you have to have a concept of role-based access control. So depending on the users and their job responsibilities, they should have access to different features of your microgrid controller, and that there shouldn't just be one authentication that allows free reign. So this is a very important aspect of providing security, a layered defense, if you may. And also, let's talk a little bit about the alarming capability. Syslog today is an open standard that allows you to take alarming data from your various technologies and put it in a format that can be easily visualized on a Splunk-like tool. So it's very important to have that capability. It doesn't really help us if you provide alarms in a silo. We have to be able to take those alarms and do something with them. And you cannot expect a human being to sit in front of every technology. We just cannot do that. So we have to be able to do data integration. And then when we want to do upgrades, and naturally all microgrid controllers have firmware and the firmware needs periodic upgrades, so how do you do that in a secure way so that there are no man-in-the-middle type attacks during that upgrade? Or if a firmware upgrade with backdoors, callback routines, malicious code is inserted, there should be some whitelisting process that says, no, this is not the firmware that is legit, and therefore I'm not going to allow this to come on. So these are the minimum features that we feel are important in order for you to play in ESIF. And then it's kind of like a funnel approach. So if you cross this threshold, then you have the basic qualities that are worthy of further evaluation. So in the further evaluation, the next phase, what we are actually going to be doing, in addition to the questionnaire that Sarah talked about, is actually seeing that can you execute what you said in the questionnaire as a yes. That's what the testing is about. So when we get to that point where I believe the 2 finalists, we're going to do evaluation. So at that point, we're going to be checking against your questionnaire, and it'll be kind of like the Miranda rights. So anything that you will say shall and will be used against you. The purpose of that is really to help protect our investment. If we're going to invest in your microgrid controller, we need to make sure that your propaganda material on .pdf lives up to reality. And we're going to be looking at 2 aspects there. One is, what security features are you providing on the technology themselves in terms of like username and password strength, for authentication, role-based access control, all the things that we spoke about. But in addition to that, we'll also be looking at how well you can integrate your cybersecurity posture with that of our research facility. So that is where we talk about systemic testing of security. So when you see this test bed that is being displayed right now, we're going to put your microgrid controller in place of our current SCADA system. And we're going to put real loads, as was being mentioned, and some simulated loads. And we're going to run use cases, standard use cases that we would normally if we were doing research. And then we would attack it. And we want to see, as we attack both as an insider and outsider, what can we get away with? And we'll discreetly feed that back to you and give you an opportunity, if through some minor changes, you can change that posture and shut those doors. And if you can, great. And if you cannot, then that will be used in the criteria for the final evaluation. So with that.
Okay, thank you. So this is my last slide before questions and answers. I just wanted to touch quickly on attribution and how we will treat your data. So the identity of the selected respondents, so the 5 people who will participate in stage 1, and the offerers, which will be the 2 people who make it to stage 2, will not be publicly announced or made known to each other at any time before, during, or after the competitive procurement. We will publicize the winner of the procurement, and of course we have thousands of visitors that come to the ESIF every year, and they, your controller will be here, so you will have that type of publicity. And but the companies that participate that are not ultimately chosen, we will not do any proactive press around unless it is something that you want us to do, and then we can talk about that. So as I mentioned, while you are here in the pre-procurement evaluation 21 weeks, we will have you enter into a non-proprietary user agreement. So please make sure that your company's lawyers are looking at that information now. It is on the website. This is just an excerpt here. But basically, anything that you invent yourselves, because we are not doing joint research with you, you may elect to retain title to that. But please do get your attorneys involved early, especially if you're a large company. We can also set up calls between attorneys if we need to do that. So that is not a problem. And you can contact me for that. My contact information is on the next slide. And I wanted to let you know we intend to publish a report or technical article based on this experience. We also intend to inform the IEEE standards working groups. What we will do is anonymize and aggregate the information from the testing results. Because there are, such a small pool, if we cannot sufficiently anonymize the results, then we will not include them in a publicly made available report. Obviously, each team will get their results, of course. All the parties will have a chance to review that before we published. The Department of Energy has requested that they get anonymized but disaggregated results, and we have agreed to provide that to them. So all of this information is in the full documents that are on the website, so can't stress enough how important it is to understand everything in those documents. And if you have questions, my contact information is here, sarah.truitt@nrel.gov. I have a phone number that I answer. I answer the phone, 303-275-4684. And we will post the answers to your questions on our website. So we won't directly respond to you, but we will respond to for everyone to see. And like I said, May 26th is the last day for questions. Now I think we can open it up for questions.
Okay, well, thanks everyone for sharing that nice presentation. We'll go ahead and get started with the Q&A session. If you have a question, please type your question into the GoToWebinar toolbar under the questions pane. We'll get to as many questions as we can. So the first question I have is it necessary to respond to the letter of interest in order to participate? What if I missed that deadline?
It is required to respond to the letter of interest. So this is the first part in the formal request for proposal, dual stage competitive procurement. So yes, you must respond.
Okay. Another question I have is, where can I get a copy of these slides? Just to let everybody know, we will be posting this recording of the webinar on the Work With Us page, on the user call page from the Work With Us page on the ESIF website. And I will also be making the downloadable PDF presentation available there with all of these slides. Does anyone else have any questions coming in, or do the speakers have any comments they'd like to add?
I have a couple more points to make. I didn't get into detail of the penetration testing that we will be doing. First, I'd like to say that it's not too much effort to respond to the LOI, so go ahead and do it. Put the time in now. There'll be a lot more work to be done later, and so try to meet the deadline. What is the deadline again?
June 2nd at 5 p.m. Eastern.
Oh, we have plenty of time. I mean, if you look at the amount of effort that's required to respond to the LOI and the number of days you have, if you've heard this message, you should submit an LOI. Because that also shows a sense of urgency to us on how interested are you in doing business with us.
Okay, great. Thank you, Irfan. I just got a few more questions. Are there any restrictions with respect to teaming arrangements?
My short answer would be no. However, it would be the restrictions that the federal government has generally. So the U.S. State Department typically has a list of sensitive countries that we're not allowed to work with, nor can people from those countries typically come on site to a federal facility. So that would be a potential limiting factor. The prime responder needs to be an actual organization. It can't be an individual. But those are really the only restrictions.
On the cybersecurity question, you want to read it?
Sure. So another question is, with the emphasis on cybersecurity, can the participants design their own networks?
Yeah. I think that if you get to that finalist level where there are just two players and we are going to do the actual testing, if you look at our network, it's an IP-based network. It has a control center site and 2 substations. If you can go back to that slide, it'll be good to show them. There is tremendous flexibility in the cybersecurity testbed. We can move things around. We can do that if it is necessary for you to show a better cybersecurity posture.
Okay.
Yes. So if you look at the network on the top right side, it's essentially an IP-based routed network. We have Cisco ASA 5512 firewalls. We have Cisco 3850 layer 2, layer 3 switches. And then we have 3 intrusion detection systems from N-Dimension, Next Defense, Sophia, and Albedo that provide intrusion detection at different logical layers. Albedo does it at business process level. N-Dimension is primarily focused at semantic and application layer. Next Defense, Sophia is focused primarily on network and TCP layer. We have 2 inline blocking tools, one from Blackridge, which provides layer 4 protection. It essentially brings application layer security controls down to the TCP layer and authenticates every TCP segment as it goes by. So that is agnostic to the technology that you're going to bring in as long as it's IP-based. And then the other inline blocking tool is from SecLab, which works on providing a hardware layer filter for the Modbus TCP protocol, and it's very granular. So you can put very tight filters on what you allow and don't allow, and then you can block things. So if you look at this test bed, it is like a coach for your microgrid controller. It will enhance your cybersecurity posture. But if you feel like you can put your best foot forward by making some network design alterations, be our guest when you are here. It doesn't take very long to do that. Other questions?
He expanded on it.
Okay.
So next question I have is, are there further details, test cases available on the KPP?
Yeah, so the KPP is like a basic measure for performance. So it's very important for us, and it will be also very important for a microgrid controller developer, because this will actually set up your goal. How can you achieve the best result? And this will be published well prior the testing phase, and it will be described in this package in the 19th of June. We will also include some test cases with that, so that it's going to be clear how to understand the KPPs. That's also something after the challenge that we would like to publish as a kind of a way of evaluating how we can evaluate the performance of a microgrid controller.
And right now, if you haven't seen it yet, on the webpage where I shared a screenshot where it says how to apply step 2, that document includes the list of KPPs. If you have not seen that yet, there's some detail there, but as Shamek said, that there will be more detail in the instructional packet that you will receive to start stage 1.
Yeah, so on the next elaborate cybersecurity question from Scott.
Just a moment here. So the next question I have is, can you elaborate on the relationship between the FIL sub-microgrid and the Banshee model microgrid? Will any testing involve only the FIL segment?
Yeah, so the PHIL, as you probably seen with this question, it can already be a small microgrid, very easy. But for the purpose of this challenge, we decided we are looking for a big microgrid controller, which is capable of controlling multiple feeder industrial type of multi-megawatt microgrid. So in both stages of this procurement, we will actually use the Banshee model together with PHIL. So they will always be working together with this big microgrid.
Yeah. So on the cybersecurity question, let me tell you how flexible we are. As long as there are some loads and there are some generation sources, and there's a microgrid controller balancing between them, and it's on an IP-based network with some routing, in other words, there are some subnets, you can bring whatever gadgets you need from your side onto this network in order to put your best foot forward. The only thing I would say is that our power systems engineering people have to look at that network design and approve it and say, yes, when we will use this, we will use it this way. That's an important part of the evaluation. As long as that's the case, from a cyber perspective, I'm agnostic to the network design. I'm only interested in the cybersecurity posture that results from that network design.
Okay, great. Thank you. Last question I have here is, can we use application-specific IP-based OT network design?
That's it.
Oh, okay.
That's what you just said.
And the answer is yes.
Okay. Okay, and the answer is yes. Do I have any more questions on the line or any comments from the speakers? As a reminder, if you have additional questions on the procurement, please direct those to Sarah Truitt at sarah.truitt@nrel.gov. And that concludes today's Q&A session. please reach out if you do have additional questions, and you can find more information on the ESIF website. Oh, we just got one more in. The question is, will there be funding available for the competition?
So there's no funding available for companies to participate in the competition. The access to the test beds does not cost the companies any money. So the Department of Energy is, I would say, supporting your use of the test beds, but there's no money is being exchanged at all.
I would,
until the procurement happens, then we will purchase.
I would add that you should look at this exercise as an investment from your marketing budget, because the bragging rights you're going to get, even if you're not selected, from getting past that first phase into where, if you get into the 5 and then from the 5 into the 2, all of that process, that constructive engagement with NREL is worth its weight in gold. Plus, you're going to learn a lot about your microgrid, because you're not drinking your own Kool-Aid. You are getting evaluated by people who have only one interest, and that is to further research in this area. So you can do plenty with this. So when you decide on putting effort into this, give it your best effort, because the payback of this is not just about getting a microgrid controller into NREL, but changing the narrative for you in the industry.
And during the event, we've factored in enough time during your controller in the loop and power hardware in the loop time frames to allow you to not just do what you need to do to show us how your controller performs. For the rest of those days, you can do your own research and development, whatever you want, while you're here in our user facility.
Okay, thank you. So just as a reminder, we'll be posting today's presentation on NREL's Energy Systems Integration website on the User Access page, which you'll find under the Work With Us drop-down at the top of the ESIF website. And we should have that up in the next couple of days. If you have additional questions, please email those to